Tanks are built to survive. 40 tons of steel, wrapped in armor thick enough to shrug off bullets, powered by engines designed to keep moving, even when parts start failing. But there's a problem. The moment something becomes hard to kill, someone, somewhere, will dedicate themselves to figuring out how to kill it anyway, cheaply, quickly, and in large numbers. And when that happens, tank crews don't wait for official upgrades. They improvise, they weld, they bolt, they stack, they pour. Because in war, survival isn't always about perfect engineering. Sometimes, it's about whatever might stop an explosion if you attach it fast enough. When people imagine World War II tank battles, they picture Europe open fields, long distances, armored duels across miles. But in the Pacific it was different. Dense jungles, visibility measured in yards, and the enemy didn't always fight from afar. If they couldn't destroy a tank from a distance, they simply walked up to it. Japanese infantry used satchel charges, grenade bundles, and magnetic explosives. They ran straight at tanks, climbed onto them, tried to force explosives inside. From inside the tank, this was a nightmare. Because no matter how thick your armor is, it doesn't matter when someone is standing on your roof, holding a bomb. So American crews came up with a solution. Simple, brutal, effective. They turned their tanks into porcupines. Large steel spikes, basically construction nails, were welded all over the tank. Around hatches, periscopes. Anywhere someone could grab, the message was clear. You want to climb this tank? You're going to bleed first. And it worked. Of course, there were downsides. The spikes didn't care who you were. Even the crew had to climb carefully. But there was a hidden advantage. Those spikes created distance and shaped charges. They work best when pressed directly against armor. Move them even a few inches away, and their effectiveness drops. Another threat was magnetic anti-tank mines. Flat, packed with explosives, designed to stick to metal. So crews adapted again. First rough paint with sand, to reduce magnetic grip. It helped, sometimes. Then came a better idea. Wooden planks were bolted onto tanks. Magnetic mines couldn't stick properly. They just fell off. And again, spacing mattered. That extra layer disrupted explosive geometry. The tank might look ridiculous, like a moving shed, but it worked. Eventually, crews took it even further. They added concrete, poured over armor, filled gaps, thickened weak spots. Protection increased, but so did weight. A lot of weight. Engines struggled. Suspension systems suffered. But when the alternative is getting blown up, mechanical problems become secondary. This wasn't just an American thing. Over time, these ideas became official. Extra armor plates, spaced armor, even specially designed heavy variants like the Sherman Jumbo. What started as battlefield improvisation turned into standard military design. And it didn't stop there. In modern conflicts, vehicles still use improvised protection. Scrap metal armor, cage armor, slat systems designed to stop rockets and drones. People might laugh at how they look, but they follow the same logic that's over a century old. Add space, add layers, make it harder for the enemy. Improvised armor isn't perfect. Sometimes it saves lives, sometimes it barely helps, sometimes it breaks the vehicle. But it always means one thing: someone refused to accept the problem. They picked up a welder and fought back with whatever they had, because in war, perfection is optional. Survival is not.